On this is 30 points of view. It says the students will extend the properties of transformations and explore the effects of transformations on the graph of a relation. Yesterday we were looking at transformations on that boat. Today we're going to be looking at transformations on more of a generic type of a function. Okay? So let's take a look here. It says the following are some values of the function f. They've given me f of negative 2 is equal to 2, f of negative 1 is equal to 1, f of 0 is equal to 3, and so on and so on. Now, if you recall, back I think it was the first week of school, we said that we could write function notation like this, or we can also write each and every one of these as points or ordered pairs. How would I write the first one, f of negative 2 equals 2 as an ordered pair?
Negative 2.
Negative 2, 2. What about the second one? How could you write that one as an ordered pair?
Negative 1.
Negative 1, 1. So what we're going to do is we're going to turn all of these into ordered pairs. As a matter of fact, we're going to put all of these ordered pairs in this table that they've given me. So as you already said, the first ordered pair would be negative 2, 2. So let's put that in the table. The next ordered pair would be negative 1, 1. The next one is 0, 3. The next ordered pair would be 1, 0. The next ordered pair would be 2, 2. I'm looking right here. 2, 2. The next ordered pair would be 3, negative 2. That's this one right here. And finally, the last one would be 4, 2. That's this one right here. So all I did was convert the function notation and rewrote them as ordered pairs. And that's what I got. Then what we did was we took each of these ordered pairs, plotted them on our graph paper, and connected the dots. For example, negative 2, 2. That's this point right here. Negative 1, 1. That's this point right here. 0, 3. That's this point right here. All we did was plot the points and then connected those points, and this is the graph that we get. So this is the function we're going to be working with today. My question to you is, why can we call this thing a function? Why can we call it a function? That's right. So the x's don't repeat. As long as the x's don't repeat, we can call it a function. That's exactly what I have here. X's don't repeat, so this is a function. So we're going to be taking a look at that function. Matter of fact, we're going to be doing a couple of transformations on that function. So let's turn the page. Oh, by the way, before we turn the page, back on this one, I need you guys to do me a favor, and I need you to circle this part for me right here. Because what's going to happen today is, as we're working, we're going to need to keep flipping back to this particular spot. In a minute, I'm going to be asking you, what is f of negative 2? So if you don't remember, here's where you're going to find it. F of negative 2 is equal to a 2. So keep that handy. All right, now let's turn the page and let's take a look at number 2. Number 2, we have y is equal to f of x plus 2. So you'll notice they've given me a graph of the original function. That's the same graph that we got on the first page. We're going to see what happens when we add 2 to the x value. So here we go. Now, you got two columns here. You got a middle column. This is where we're going to put the process or what we're doing. The y values are the answers that we get. So here's what we're going to do first. First, we're going to take out this x right here. And all we're going to do is replace it with the x values that we're given. The first x value I'm given is a negative 4. Now, don't write too big because we've got to squeeze in quite a bit of stuff. So all I did was take out the x and replace it with a negative 4. So my question is, what is a negative 4 plus that 2 there? Negative 4 plus 2 would be a negative 2. So now what I have is f of negative 2. Now remember a second ago I just told you that we're going to have to keep flipping back and forth to that first page. What I need you to do is flip to the first page. Look at that thing I had you circle. And what I need you to do is look for f of negative 2. What is f of negative 2? 2. So that's what you're going to put for the y value, 2. Put that in there. This is why I say we're going to have to keep flipping back and forth. Let's do the same thing with the next one. Let's replace the x this time with a negative 3. So if I take the negative 3 and add 2, negative 3 plus 2 is a
1.
what kind of one? Negative 1. However, you're going to need to flip to that first page again and look it up for me. What is f of negative 1? F of negative 1 is 1.
Wait, these are the same graphs, right?
Well, this is the same graph as the one on the first page. This is the original function. What we're doing is adding 2. We're going to see how this new graph we get compares with the original. So we're going to get a different graph here in a minute.
For right now,
So the answer's on the other page.
Yes.
We got to solve it.
Yes.
for right now, you're looking for your y. Once you
Yeah,
figure out
you-
your f of 1, can't you just look on the graph?
You can also look in the graph, yes. Some of us can do it from the graph, some of us prefer looking at this over here. But if you can tell from the graph, yes, it's the same exact thing. Over here, let's try the next one, negative 2. F of negative 2 plus 2. Well, what do I get when I add a negative 2 plus 2? You get a 0. But what is f of 0? F of 0 is a, go back to that first page, what is f of 0? 3. So that's our y value, 3. Try that again. Let's replace the x with a negative 1. Negative 1 plus 2. A negative 1 plus 2 is a 1. If you look back on the first page, what is f of 1? F of 1 is a 0. So that's what's going to go in here for my y, 0. Now let's plug in a 0. 0 plus 2. 0 plus 2 is 2. You look on that first page again, f of 2. F of 2 is going to be a 2. Now let's plug in a 1. 1 plus 2. 1 plus 2 is 3. So what I have now is f of 3. And if you look that up on the first page, f of 3 is equal to a negative 2. And one more here. If I plug in a 2 for the x, 2 plus 2 gives me 4. If you look back on the first page, f of 4 is equal to a 2. So after it's all said and done, I've got some new ordered pairs. What we're going to do now is we're going to take these new ordered pairs, plot them, and see what kind of graph I get this time. So let's plot the ordered pair negative 4, 2. Find negative 4, 2. That's right here. The next ordered pair you have is negative 3, 1. Right here, negative 3, 1. I'm going to connect the dots as I go. Negative 2, 3. Find negative 2, 3. Connect the dots. Negative 1, 0. Connect the dots. 0, 2. Connect the dots. 1, negative 2. Connect the dots. And the last one we have is 2, 2. That's right here. Just connect the dots. So here's the new graph. That's the new graph. My first question is this graph we have now, is it the same basic shape as the original function? Yes, the shape is still the same. But what do you notice happened to that shape?
They got moved to the left.
It got moved to the left. Can you tell how many times it got moved to the left? 2 units. So notice what happens here, guys. Let's see here. This is the same exact picture of what we started with. Okay? It's exactly the same shape. All it did was move over 2 units to the left. And what do you think caused that moving 2 units to the left? The plus 2 that we have right here. So all that plus 2 did to the graph was move it over 2 units to the left. So what do you think would happen if I had a plus 3 in there? It would have moved 3 units to the left. What if it said plus 5? 5 units to the left. So all it's doing is moving it 5 or 6 or 7 or 8 units. It depends on what we're at. So with that said, if you take a look at number 3, You're going to come back and do that one in a minute. But if you had to guess, what do you think is going to happen on this
It's
one?
gonna move to the right.
It's going to move to the right how many? 2 units. And what would cause that moving to the right 2 units? The -2. But you'll check to make sure here in a minute. You'll do that one on your own. Once you get those 2 complete, you're going to answer number 4 for me. What do you notice about the graphs? Okay? Let's go to number 5. Go to number 5 now. Notice on number 5, we're going to add 2 again. But this time, the addition is on the outside of the parentheses. This time we're adding 2 to the function. It's not inside the parentheses, now it's on the outside. So it's going to work a little bit different here, guys. Here's what I'm going to do so we can save time. Instead of flipping back and forth to the first page, I've got the same thing right here. Okay, so it's all up here. So the first thing we're going to do is take this x right here, and we're going to replace it with each of the x values in the table. Let's start with the -2. If I put a -2 in for the x, f of -2, what is f of -2 according to our table up here? F of -2 is a 2. So put that in there. That's not quite it though, right? Because I still got to add 2. So the 2 that I got earlier plus this 2 right here would give me a 4. So my new y value is 4. Let's try that again. This time let's plug in a -1. So f of -1. If I look over here, it says that f of -1 is a 1. But that's not the answer. Now what I need to do is add 2. That's this 2 right here. So 1 plus 2 is going to give me a 3. Try that again. 0. If I plug in 0 for the x, f of 0. F of 0 is a 3. But if I add 2 to that 3, 3 plus 2 is going to give me a 5. So my new y value is 5. Again, if I plug in a 1, f of 1. F of 1 is 0. Add 2 to that 0. 0 plus 2 is 2. The new y value is 2. Plug in a 2. F of 2. F of 2 is 2. You add 2 more. 2 plus 2 is 4. 3. Plug in a 3. F of 3 is -2. And -2 plus 2 gives me 0. And then the last one, if I plug in a 4 here, f of 4 is 2. And 2 plus 2 gives me 4. So these are the new order pairs that we get this time. So let's come over here and plot the points and see what happens with this graph. -2, 4. Let's find -2, 4. That's going to be right here. -1, +3. -1, +3 is right there. Connect the dots as you go. 0, 5. 0, 5 is right here. Then I had 1, 2 here. 2, 4 is the next one. That's this point right here. Then I have 3, 0. It's going to be down here. And the last one I have is 4, 4. That's this point up here. Alright, so there's the new graph. What do you notice about the 2 shapes? They're exactly the same shape. What happened to our one? All that happened was it moved 2 units up. So again, if you look closely here, all that's happening is it's the same exact graph, same thing. All we're doing is moving it up 2 units. And what's causing that? Moving up 2 units, this plus 2 here. So again, what if it had said +3? It's going to move it up 3. It says +10. What is it going to do? Move it up 10. Well, if you had to guess here, what do you think the -2 would do to the graph? Bring it down 2 units. Okay, so adding, move it up. Subtracting is moving it down. You're going to do that one at number 7. Now let's go to number 8. Number 8. I'm going to see if you can figure out number 8 before I give it to you. I'll give you a minute or two. See if you can come up with the value on number 8. Number 8. We're not adding, not subtracting, this time we're multiplying. What happens when we multiply? Here's those numbers so you don't have to keep going back and forth. All right, everybody got it? What do they want me to do with the x value? What do you need to do when you have a 2 next to an x? Multiply. The operation here is multiply. So we're going to multiply each of the x values by a 2. So the question is, what is 2 times a negative 1? 2 times a negative 1 is a negative 2. That's not the y value though. You need to look at the front of your page, or right up here, f of negative 2. What is f of negative 2? It's a positive 2. That goes in there. That's our new y value. Let's do the next one here. We're multiplying. We're multiplying the 2 times the negative 0.5. What's 2 times the negative 0.5? Negative 1. But what is f of negative 1? F of negative 1 is positive 1. Next one, 0. If I plug in a 0 here, 2 times 0. 2 times 0 is 0. If you look over here, it says that f of 0 is equal to a 3. Next one. Now we're multiplying 2 times the 0.5. 2 times 1/2 is a what? Positive, sure? Positive 1. And what is f of 1? F of 1 is a 0. 2. Now we're multiplying the 2 times this 1 here. 2 times 1 is 2. What is f of 2? It says right here that f of 2 is equal to a 2. Next one, 2 times 1.5. 2 times 1.5 is 3. And f of 3 is a negative 2. And then the last one, 2 times 2. 2 times 2 is going to give you a 4. And f of 4 is 2. So these are the new points. These are the new ordered pairs. Let's plot them and see what happens this time. Negative 1, 2. Find negative 1, 2. Then let's find negative 1/2 and 1. Negative 1/2 and 1 is going to be right here. 0, 3. Find 0, 3. Connect the dots. 1/2 and 0. That's right here. 1 and 2. That's up here. 1.5 and negative 2. 1.5, negative 2 is going to be right here. And then finally, the last order pair is 2, 2. That's going to be this one over here. So there's our new graph. There's the new graph. Is it the same basic shape?
Yes.
Well, the same basic shape, but what happened to it this time?
It got smaller.
It got a little smaller. It didn't move up, it didn't move down, it didn't move left, it didn't move right. All that happens is it got smaller. I want you to think about what happened there. Why did it get small? And then you're going to write it down for me on number, I think it's 10. You're going to do number 9, and then you're going to answer number 10. What do you notice about the two graphs? All right, let's go on to number 11. We're going to multiply again. But this time the multiplication occurs on the outside of the parentheses. So now it's 2 times f of x. So this is going to work a little different here, guys. Let me bring the numbers up. So just like we did on all the others, we're going to replace the x with all the values in the table. So first I'm going to start with a -2. Let's forget this 2 for a second. Just forget about that. What is f of -2? F of -2 is, what does it say up there? +2. However, in front of this f of x, we had a 2, which means we need to be multiplying by 2. So 2 times 2 is going to give me a 4. So my new y value is 4. Now let's plug in a -1 for the x. What is f of -1? F of -1 is a 1. But we need to take that 1 and multiply it by this 2 right here. So 2 times 1 is going to give me a, no, 2 times 1 is 2. 2 times 1 is 2. 0. Let's plug in a 0 for the x. F of 0. According to this, it says that f of 0 is a 3. But we're going to take that 3 and multiply it with the 2. So 2 times 3 is going to give you a 6. Plug in a 1. F of 1. F of 1 is 0. But if you multiply that 0 times 2, 0 times 2 is 0. Plug in a 2 now. F of 2. F of 2 is 2. And if you multiply the 2 times this 2 in front here, 2 times 2 gives you 4. Plug in a 3. F of 3 is a -2. And 2 times a -2 will give you a -4. And the last one, if I plug in a 4 here, F of 4 is 2. And 2 times 2 is going to give me a 4. So these are the new y values. So we're going to see what happens to the graph this time. -2, 4. Let's find -2, 4. Then we'll find -1, 2. Connect the dots as we go. 0, 6. That's up here. 1, 0. That's down here. 2, 4. 3, -4. It's way down there. And then we got 4, 4. This point up here. Alright, so this is our new graph for number 11. Do we still have the same basic shape? Yes, we do. What happened this time? What's happening to the graph? Getting bigger. Okay? Now I want you to think about why. Why is it getting bigger? You're going to write that down for me. Not on number 12, but on number 13. Compare the graphs to the original function. Let's keep going here. Number 14. 14. Told you, it's 7 pages. A lot of stuff we got to get to. We got 2 more that we're going to do together, and then you're going to be on your own. We're almost there.
2 more graphs?
2 more graphs. Okay, next one. Here we have y is equal to f of -x. Just like I've done with all the others, we're going to start by replacing the x with each of these x values. But you'll notice there's a negative sign here. And that negative means we're going to change the sign. We're looking at the opposite. So for example, that negative sign right there times that -4 right there, a negative times a negative makes this a +4. So now what we're looking at is f of +4. And what is f of +4 according to this little chart over here? It's a 2. So all we're doing is changing the signs. Let's try that again. This negative sign times this -3. Negative times negative makes this a +3. And if you look at the chart over there, f of 3 is equal to a negative 2. Next one. This negative sign times that negative 2. That negative times that negative makes this a positive 2. And f of 2 is equal to a 2. Next one. This negative sign times this negative 1. Negative times the negative makes this a positive 1. And according to over here, we've got f of negative 1, or positive 1 is equal to a 0. The next one we have, the negative sign times 0 is still going to be 0, f of 0. And as you can see over here, f of 0 is equal to a 3. Next one, this negative sign times this 1. Negative times 1 is a negative 1. And if we look here, f of negative 1 is equal to a 1. And then the last one, that negative sign times that 2. Negative times 2 makes this a negative 2. And if you look here, f of negative 2 is equal to a 2. So these are the new points. These are the new order pairs. So let's go ahead and plot this and see what happens. Negative 4, 2. Find your negative 4, 2. Then find negative 3, negative 2. Connect the dots. Negative 2, positive 2. Negative 2, positive 2. Negative 1, 0. 0, 3. 1, 1. And 2, 2. All right, so there's my new graph. Do we still have the same basic shape?
It just
Yes. What happened this time?
flipped it over the y-axis.
We flipped it over the y-axis. What do we call a flip? Reflection. So what you're looking at is a reflection. Everything that's on the right side of the y-axis is now over here on the left, and everything that was on the left is now over here on the right. So it's a reflection. Everything's flipped. All right. And of course, what caused that flip is that negative sign there. Number 15, you're going to try one. Notice the negative sign is on the outside, so keep that in mind. Once you get that done, make sure you answer questions 16 and 17 for me. We got one last graph to look at, number 18. 18. Now notice number 18 has some bars around the f of x. Anybody remember what those bars are?
Absolute value.
Absolute values. We're going to be working with some absolute value here. So first thing I want to know is what is f of negative 2? What is f of negative 2? Says up there in the table, f of negative 2 is 2. But that's not the answer yet, because I still need to take the absolute value of that 2. And what is the absolute value of the 2? You guys know how to use your calculator to find the absolute value? All right, turn on your calculator so I can show you how to do that. All right, the way you get absolute value, make sure you got a nice clean screen there, nothing on it. You're going to go to math. Then you're going to move to the right one, up at the top where it says NUM. The very first choice you see there is ABX, absolute value. You're going to select that one for me. And when you select it, you're going to see the two little bars. Once you have the two little bars, then you can go ahead and type in the number, which in our case is 2. And the absolute value of that 2 is what? 2. So the y value is 2. Let's try that again. Let's take out the x, replace it with a negative 1. If I look over here, f of negative 1 is a 1. And if I take the absolute value of 1, I'm going to get a 1. Absolute value of 1 is 1. Plug in 0. F of 0 0 is 3. If I take the absolute value of 3, you're going to get a 3. Now let's plug in a what? F of 1. F of 1 is 0. And what's the absolute value of 0? Absolute value of 0 is still a 0. Next one, let's plug in a 2. F of 2. F of 2 is 2. And the absolute value of that 2 is 2. Next one. Plug in a 3. Right over here it says that F of 3 is a negative 2. And what is the absolute value of a negative 2? Positive 2. And one last time here. 4. F of 4 right here says it's a 2. And what's the absolute value of 2? It's a 2. Absolute value is just the distance from 0, guys. It's always going to end up being a positive value. That's why we keep getting these positive numbers. Notice how this negative 2 turns into a positive 2. All right, so let's go ahead and take a look at the graph. The first order pair we had was negative 2, 2. That's this point right here. Then we had negative 1, positive 1. That's this point right here. Connect the dots. 0, 3. Connect the dots. 1, 0. Connect the dots. 2, 2. Connect the dots. Where are we at? 3, 2. Now, I'm not going to connect the dots yet because they left a couple of them out. So don't connect the dots from there. The last one we have is 4, 2. That's this point over here. They left out 2 points here, guys. What really should happen is this graph is going to do this. It's going to come down till it hits the x-axis, come back up to that point, down, and then up. It's going to kind of look like a W there. So draw that point. This is what the graph looks like. Now, if you look there, almost the whole thing is exactly the same thing. But what changed? What's different? Yeah, if you look down here, what happened to this piece of the graph?
It got reflected across
There. There it is. What happens is it got flipped up into that first quadrant. And why is that? Well, because we were looking at absolute value. And when you're working with absolute value, you're always going to get what kind of numbers? Positive. So we can't have anything below the x-axis. Because anything below the x-axis will have negative y values. And that's not what we have over here in our ones. All right, so you're going to do number 19 for me. You've got another absolute value, but this time it's inside the parentheses. And then you're going to go ahead and answer questions 20 and 21. So you're going to finish up the rest for me. If you want to work with a buddy, that's fine, but make sure you are working. This is going to be taken up before we leave here for grade. Do not waste time. We all finish before we leave.